Welcome back to class. Instructs, the structures chapter we're studying. The second topic is bit fields. Why do we use bit fields? Bit fields are a process of creating compact structures and not adding any information which is not necessary. For example, we have to add a number which fits in 3 bits or 4 or 5 or 10, 12 bits. We should not be using larger data types and storing them onto disk. So we have to create a really compact structure by changing the fields within the structure and setting their maximum length in the bits. And that would be done through a very good example, that I think is a very good example, is storing the date. So let's create a structure for the date and try to understand how bit fields, these fields which have a modified version of number of bits, are called bit fields. So we create a structure as we did previously, type def structure, and then we start to create the structure here and then name it. For example, we say underscore date, or maybe date underscore t, date type. Fine enough. So in here, we use some integer for the day. Now we can use character for the day, of course. So the day value of the day is can be stored in 5 bits. Why? Because 2 raised to the power of 5 is equal to 32. And maximum date is 1 to 31. So we can store in 5 bits. So what we do here is we create, for example, we say unsigned integer, take, and we call it day. So it's normal that we usually do. It's unsigned integer, and we also studied UINT, 32 underscore t, we use that one as well. Let's use those here instead of writing the long unsigned int, etc. How do we modify it to hold maximum 5 bits value? And if the value is larger than the 5 bits, the integer will overflow and go back to 0. So we will just add here full colon and the number of bits that we need to store in this variable. Then we create yet another variable and we call it month. Let's remove this str. So, and then we create yet another unassigned integer 32 of the type year. But for the month, actually there are 12 months. So 2 raised to the power 4 is value is 16. So we can use 4 bits here. Fine enough. Let's align them so that we know how many bits we are occupying for each of the field. And for the year, 2 raised to the power 11 is 1024. And 2 raised to the power 12 is 4096, which gives us 2000 more years to store easily. So we will use 12 bits here. And our date structure is ready to be used now. So what we do is we create a variable first. D, for example, we say d dot day is equal to, for example, 31. And in 5 bits, you can store maximum value is 31. Total 32 values in 5 bits, and 0 to 31 means 32 values. So we store day. And day, for example, is 31st when I'm recording this lecture for you of July. And that is the month. And the year is 2023. Now let's check out the size of this structure. Most interesting part here. Usually, a signed integer or unsigned 32-bit integer is going to occupy 4 bytes. So we have 3, which equals to total of 12 byte structure. This should be 12 byte structure, but let's see what it gives us here. We say size of the date underscore field, and that's it. Let's compile this program and run this program, and it says 4 bytes only. Why? It says 4 bytes because the structure is now compact and it has bit field. Only that part of the structure is going to be utilized, which is holding the data at the moment. So when we write it to the disk or read it from the disk, it's going to be 4 bytes only. But when we have the structure, the system will automatically adjust the data into the structure. That is a huge advantage of using C language. So you do understand now. So 21 cannot be stored, of course, and some alignment data. The structure itself is going to be added and 4 bytes. So practically 32 bits are being written down, which is brilliant. We have compacted, we have compressed the data using bit fields. Simply, we did not apply any compression algorithm. We only gave the range of the integers. We reduced the range of the integers to certain number of bits. Instead of using 32 bits, we are using 5 bits here. Instead of using 32, we are using 4. And instead of 32, we are using 12 bits here. So practically, the information is correct. And if you assign a additional value, integer normally can hold 32. But this day won't be able to hold 32. And let's print it out and check it. %d, instead of printing the size, we will print the day. And let's compile the program, build the program, and run it. The value is 0. Why? Because the maximum value of 5 in a 5-bit integer would be 0 to 31. So it is 32 is overflow and is going to create a value of 0. That's it so far with the bit fields. It's a very interesting topic. We're going to discuss it further. We need it in the upcoming lectures. If you have any question, please let me know. I'll be answering in the forum. Thank you.